Hello everybody, this is Dr. Harrington. Today we're going to do Lecture 6, which covers Section 2.2 and 2.3, Polynomial Functions and Quadratic Models. So let's first start off with what is a polynomial. So definition, a polynomial function of degree n is a function of the form some number times x to the n plus some number times x to the n minus 1 plus some number times x plus a sub naught. Now the first thing you want to notice is that the first term that we look at, the a sub n cannot be equal to 0. All right. Okay. The second thing is these numbers here, this a sub n minus 1, a sub 1, a sub naught. This is just a fancy way of saying they're just numbers. Okay. And we have a special name for them. They're called coefficients. And n has to be a non-negative integer. And a sub n, the first one, the one that I have highlighted there, the one that's not 0, that also has a special name called the leading coefficient. So the word leading means it deals with the one that's the highest degree. It'll make more sense when we start doing some examples. So for example, if I said determine if the given function is a polynomial and if or not, and if so, find its degree. So the first one here is I have some number times x to the 8th minus 2/5 x to the 6th minus 4x squared plus the square root of 3. Now there's a couple things to note here. You may say, well what about the x to the 7? That's not in there. But remember, I'll write this in here just so you can see it. You can think of that as plus 0 times x to the 7. So just because it's not there, you can think of it as 0 times x to the 7. So technically it's all there. In fact, this last little guy you can think of with the square root of 3, you can think that of as x to the 0. So the definition still holds. Now, the question is this a polynomial? The answer is yes, because it's some number times x to the 8th plus some number times x to the 6th, so forth and so on. So the answer is yes, this is a polynomial. Now, a couple people may ask, well, gee, what about this square root of 3 or the 4 or even this is a fraction? Remember, the coefficients can be any value at all whatsoever. So I want to make a note here that coefficients can be any value. So the coefficients can take on any form. Coefficients are just real numbers. Okay, the next thing I need to ask is, what is the degree? Remember, the degree is the highest power. So the degree I have is 8, 6, 2, 0. I can even include the 7 if I want. But which one is the highest? And the answer is the 8. So that's what we use to determine the actual degree. So the answer is the degree is going to be 8. So that's our two answers for that. The second one, I have 1 times x to the 3rd minus 2 divided by x plus 4x squared. Now, it may look like this is a polynomial, but this is going to be our problem. We have a negative 2x here in this particular term. Let me rewrite this a little bit so you can actually see it a little bit better. This looks like negative 2x to the negative 1. This is the problem. That is a negative value. Remember, we cannot have negative exponents. Remember the definition is what I underlined here. Non-negative integer. That is a negative integer. So what we see here is this is actually not a polynomial. Now, a couple things. One is, as soon as one term's not a polynomial, the whole thing is not a polynomial. So I don't have to keep going and keep checking all the other terms. As soon as one's not a polynomial, I'm done and I can stop. Also, it doesn't make sense to talk about a degree if it's not a polynomial. So the degree, I can't answer that because it's not a polynomial. Note the domain of a polynomial function. Remember, the word domain simply means what can I put into the function? And the answer is I can put anything in there. So the actual domain is -infinity to infinity, or all real numbers. Now there's a couple of polynomials that are very special, and we need to know the names of those. A polynomial function of degree 1, let me just write it out from the definition. That's going to look like this. F of x is equal to a sub 1 times x to the 1st plus a sub naught. Now, this may not look familiar, but let me write it a different way. Instead of calling this a sub 1, I'll just call it m times x, and then instead of a sub naught, I'll call it b. So guess what? You have been doing this before. It's just called a line. In fact, anything of degree 1, polynomials of degree 1, they're just lines. So you actually studied those before. So they're just lines. All right. Now, quadratic functions we have a polynomial function of degree 2 is written of this form. Again, the first term cannot be equal to 0. If it is equal to 0, it's actually a line, so it's not a quadratic. And it has a special name called a quadratic function, so hopefully you've seen that before. Another way of writing this, we typically write it as ax squared plus bx plus c, and you've probably seen things like the quadratic formula and other things, which we'll actually get to in this class too. Now we want to graph the following function. Now the first thing you want to note is this is actually even if you try to put it in there, because if you put it in a negative x, you get negative x squared. Remember, squares make everything positive. So if I make a little table here, if I have x and y, and I just take a look at what the values are, I have negative 2 squared just turns into 4. Negative 1 turns into negative 1 squared, which is 1. 0 squared is equal to 0. And 1 turns into 1 squared, which is 1. And 2 turns into 2 squared, which is 4. So you notice this really nice symmetry. Whatever I did on the side that was negative is exactly the same as if it was positive. And that's because it's an even function. Remember, we want to exploit the geometry as much as possible for some of these functions. So here, if I graph this out on the x and the y-axis in Cartesian coordinates, first I start off with the origin, that's 0, 0 from the first part. And then the next one I can do is 1, 1. And then because of symmetry, I'll also do the other side, negative 1, 1. And then if I come over here 2 units, 1, 2, and then I go up 1, 2, 3, 4. I get that piece over there. And if I go over negative 2, 1, 2, it's also going to be 4. So you get this nice symmetry across these two. Now let's see if I can draw this really well. It's kind of hard to get it to look nice. This is going to come up. Alright, hopefully that's the best I can do. But that's going to be our graph. And again, these points here, like for example, this is going to be 2, 4, 1, 1, and 0, 0. So it's basically the same as the symmetry over here. So we're going to have negative 1, 1 and negative 2, 4. Okay, so remember we talked about translations and shifts? Well, we can apply that to the same thing to quadratics. So over here, the first thing I'm going to do is shift it to the left 3 units. So again, I start off with the normal quadratic. I'll just kind of put little dots here. I'll just do a little quick dash lines. So this thing that I drew here, this is actually y is equal to x squared. The first thing I'm going to do is I'm going to shift it to the left 3 units. So that's going to go to the left 3 units. That's the first thing I do. So I'm going to go over 3 units. 1, 2, 3. That's negative 3. So notice now, instead of going through 0, 0, it now goes through negative 3, 0. And again, from symmetry, everything is just shifted over 1 unit. So this is what this particular piece is going to look like. Hopefully we can see that. So the one I drew here is just y is equal to x plus 3 quantity squared. The second thing I'm going to do, and I'll do this in a different color so we can see it, is I'm going to flip it across the x-axis. So that's the second thing that I do. Now if I flip this to the second, if I flip 0, well that's still 0. So again, it's still going to go through the point negative 3, 0. And I'm going to flip this point down 1, and I flip this point down 1, and it just kind of goes down. So the part that I have in red is the actual graph of the curve. And again, this is the y is equal to negative x plus 3 quantity squared. Now, a lot of students can do all this in one step. I just broke it down into all the different parts. Now, notice that negative 3, 0 is the actual vertex, or the apex, or how high the parabola goes. We'll learn all those terminology in a little bit. And notice you can actually see that. See, this is, think about it as plus 0 here. If you think about it as plus 0, let me just put a little plus 0 here. So you can see the negative 3 there, and then the 0 goes right there. So there is a pattern to this, which we'll exploit in a little bit. Now again, let's try this one, x minus 2 quantity squared plus 1. Alright, so the first thing I'm going to do is I'm going to graph x squared so I can take a look at that. So that's just going to come down. Again, I'm just going to use it real lightly. If you have a pencil, you can just sort of do that kind of light. That's my y is equal to x squared. The first thing I'm going to do now is I'm going to shift it to the right 2 units. That's the first thing I do. So I'm going to go over 2 units. 1, 2. That goes down. And then I'm going to plot those points. So that's going to come here and here. So again, if I do that ever so lightly, So that's what that kind of gives you the idea of that. That's going to be x minus 2 quantity squared. And notice it goes to the point here, 2, 0. Now again, in red, I'll go ahead and put down the last step. I'm going to shift it up 1 unit. That's the last thing that I do. And again, when you do the order of operations, you always kind of go from inside out. If you do any other kind of operations, it's not going to work. So if I move up 1, notice that that point is now 2, 1. And then if I put another point down, again, I'm just shifting everything 1 unit. That's going to look like, and if I put in, let's see, if I put in 0, I should get 5. 1, 2, 3, 4, 5. So the graph is going to look something like this. It's going to come up by symmetry. So the one that I have in red is the actual correct answer. So I just shifted it to the right 2 units, and then I shifted it up. And again, most students can do that in 1 step. So the red here is going to be y is equal to x minus 2 quantity squared plus 1.